Good evening, students. Today I am going to discuss a very important chapter of mathematics, trigonometry. So before we start trigonometry, let us try to understand where do we use the concept of trigonometry and how to find the solution of real life problem with the help of trigonometric ratios. So let us take a situation. A little boy, Jack, went to a park and saw that there is a very tall building. Now, Jack wondered if he can find the height of this building. Suppose the height of this building is h. Jack want to find the height of this building without actually measuring its height. Okay. Now let us take another situation. There is a little girl, Anna. Anna saw an aeroplane flying in the sky. Anna noticed that after some time, this plane traveled to a distance and reached to a point B. Suppose this point is A and this point is B. Now Anna want to find the height of this aeroplane and speed of this aeroplane. So in both the situation, we can imagine a right triangle drawing some imaginary lines. So if I draw an imaginary line which is parallel to the horizontal and a line which is along the line of sight, so we can see that this is a right triangle perpendicular to the base, right? If I take this as horizontal line base, so this building will be perpendicular to the ground. Similarly, if I draw an imaginary line parallel to the ground, so we can find two right triangles just like that. Okay, so we have, in this situation we can find a right triangle, and in this situation we have two right triangles, right? So with the help of trigonometric ratios we can find the solution of our problem. That is, we can find the height of this building and height of this aeroplane as well. Okay, so before we solve our problem, let us try to understand the trigonometric ratios. What are trigonometric ratios? Okay. Now consider a triangle ABC which is right angled at B. Okay. Now in this triangle, the side opposite to right angle is called hypotenuse. And we left with two acute angles, angle A and angle C. So with respect to angle A, the side opposite to this angle is called perpendicular, and adjacent side is called base. Now mind it, if I change the angle, the perpendicular and base will also change. For example, if I take the acute angle, angle C, so with respect to angle C, this side, that is side opposite to C, will be perpendicular, and adjacent side will be base. Okay. Now, and hypotenuse is AC. Mind it. In any right triangle, side opposite to right angle will be hypotenuse. So it will not change in any situation, and base and perpendicular will be defined with respect to the acute angles A and C. Okay. Now we will define the trigonometric ratios. So the trigonometric ratio of angle sin A, that is sine of angle A, is defined as perpendicular upon hypotenuse, and in this triangle you can see with respect to A perpendicular is BC. So sine of A will be equal to BC upon AC. Now I will define another trigonometric ratio, that is cos A. Cos A is base upon hypotenuse, and in this triangle with respect to angle A, base is AB and hypotenuse is AC. Similarly, I can define another trigonometric ratio, tan A. So tan A is perpendicular upon base, that is BC upon AB. Now let us take another trigonometric ratio, which is cot A. Cot A is base upon perpendicular, that is AB upon BC. Similarly, I can define another trigonometric ratio, that is sec A. Sec A is hypotenuse upon base. Here hypotenuse is AC and base is AB. And the last one is cosec A. When we take the ratio of hypotenuse to the perpendicular, then we got cosec A, cosec of angle A. So for angle A, hypotenuse is AC and perpendicular is BC. Okay, so here we have 6 trigonometric ratios. With the help of this trigonometric ratio, we can relate the angle with the ratio of side, right? So here trigonometric ratio basically gives us a relationship between angle and length of sides of a right triangle. Alright, so if I have an angle, that is measurement of this angle and one side, I can find another two side, right? Okay, and if I find sine C, that is sine of angle C, so here you can see that sine is perpendicular upon hypotenuse. So for angle C, perpendicular is AB and hypotenuse is AC. Alright, now you can see that if I take angle C, so sine C will be AB upon AC. Alright, now from these relations you can define, here you can see sine A is perpendicular upon hypotenuse and cosec is hypotenuse upon perpendicular. So from these two relations, and I can find that sine A is equal to 1 upon cosec A. That is sine and cosec are reciprocal to each other. Similarly, cos and sec are reciprocal to each other. So cos A is 1 by sec A, and similarly you can see tan A is 1 by cot A. So here is the relation between these trigonometric ratio. Now we have a trick to remember these ratio. So just make a table and write P B P H H B. Alright, and write here sine, that is sine is perpendicular upon hypotenuse, then write here cos, and here tan, then here cot, and here sec, and here cosec. Alright, so sine A is reciprocal to cosec A, similarly cos A is reciprocal to sec A, and tan A is reciprocal to cot A. So this is the shortcut method to remember these ratios. Okay, now let us try to find the ratio of for some right triangle. Now question is, find the following trigonometric ratios in a triangle ABC, right angled at B, and AB is equal to suppose 3 centimeter and BC is equal to 4 centimeter. So let us make a triangle. A, B, C, right angled at B. Here we have given AB is 3 centimeter and BC is 4 centimeter. Okay, and we have to find sin A, cos A, tan A, cot A, sec A and cosec A. Also we have to find sin C, cos C and tan C. Mind it, here sin A is not the multiplication of sin into A. Okay, mind it, it is not the multiplication of sin into A. In fact, sin is operated on the angle A. Alright, so now we know that with the help of Pythagoras theorem I can find the hypotenuse. Here AC is hypotenuse and BC is perpendicular for this angle A, and AB is base for this angle A. So we know that hypotenuse square equal to perpendicular square plus base square. Okay, so with the help of this relation, it is called Pythagoras theorem. We have already studied Pythagoras theorem in class 9th. So hypotenuse square will be equal to, perpendicular is here 4, that is 4 square, plus base is 3. So from here h square is equal to 25, so h equal to 5. Now let us find sine of A. So sine of A, we know that sine is equal to perpendicular upon hypotenuse. So here for this angle A, perpendicular is BC, that is BC upon hypotenuse is AC. So sine A is equal to 4 upon 5. Similarly I can find cos A. Cos A is base upon hypotenuse. So here base is 3 centimeter and hypotenuse is 5 centimeter. Similarly we can find all the trigonometric ratios with the help of the formula we have given. Now let us try to find sin C. For this acute angle C, mind it, now perpendicular is AB and base is BC. So here sin C will be equal to perpendicular upon hypotenuse, that is perpendicular is here AB and hypotenuse is AC. So sin C will be equal to 3 upon 5. Okay, so in this way we can find all the trigonometric ratio of these two acute angles. Okay, now let us try to find the solution of our problem. Initially I had a problem that there was a tall building of height h and a little boy was observing this tall building. So let us make a right triangle. Here you can see ABC is right triangle, right angle at B. So you know that this horizontal distance is simple to measure. Suppose this horizontal distance is x units, okay, and this angle is theta. And if I want to find the h, so I must have a relationship between h and x and theta. Okay, so here you can see with respect to this theta, this side is perpendicular and this side is base. So I can use tan theta. So tan theta will be equal to perpendicular upon base. So here perpendicular is h, that is height of that building, and base is distance of jack from foot of the building. Okay, so see, if I know this base, which is I am taking as x units, so from here I can see h will be equal to x tan theta. Now question is how to find this tan theta. So we have a trigonometric table for certain ratio. We have a table and we can find the tan theta with the help of that table. For example, if I have theta is 30 degree, then in that case the height of building will be x tan 30, and from table we can observe that x h equal to x into tan 30 is 1 by root 2, 1 by root 3, sorry. So h is equal to x upon root 3. That is our answer. So here we will be given, or we can measure the distance between foot of the building and the jack, and from the trigonometric ratio table we can find the value of tan 30 degree. Okay, and just put the value of tan 30 here, we will have the solution of our problem. Okay.